Welcome. This is the video for 84 and 85. Let's do it. Now, right off the bat, I'm eliminating A. My answer is not A, but let's read the question and we'll address that. So if your first guess was A, that's not right. We're going to take a look at why. It says, some volunteers went out and polled some people right before an election, but they had a game plan. They decided closer to the election to talk to twice as many people. Why did they do that? Okay, so if you talk to 100 people and 8 out of 100 don't respond, okay. If you talk to 200, if 8% don't respond, that just talking to more people doesn't necessarily help your non-response rate. So you should think of this as your non-response rate. You ask more people, yes, you're right, more people probably won't say no, but that's not why you ask more people. No. Okay, why would we ask more people? Well, think of it in terms of the election. If you had an election, the person that you're working for, let's say you were working for Donald Trump before he got elected, and he wants to know how many people said yes or no. But he wants you to say, does it make sense? He wants you to say, well, I think 49% are voting for you, plus or minus 5%. And he's like, no, I want more exact. I need as exact as possible. So that's really the answer. The answer here is E. I want to be more exact. So that's about the standard deviation of the statistics. So let's look at our two standard deviation calculations. If this was a mean question, if we increased N, we're reducing the standard deviation. And so that's this idea of plus or minus your guess, what average you are away from the mean. So by increasing N, whether it's a mean question or a proportion question, notice making N bigger, because we're dividing it, will make a smaller number. And that standard deviation would mean less variability. So the lower the standard deviation, the less variability. So or spread. So let's assume some basic numbers. If they gave us numbers in the problem, let's say you asked, and half the people you asked said, yes, I'm voting Trump, and half said, I'm voting for Clinton. This would be your statistic. Half said yes, half said no. Over 100, take the square root. So you can tell them, Mr. Trump, half said yes, plus or minus 0.05. Closer to the election, you're trying to be more accurate. So you had, let's imagine you got the same answer. Half said yes, half said no, but you doubled the amount of people you asked. So you asked 200. Now notice this standard deviation is smaller, plus or minus 0.35. So variability and spread outedness gets smaller when we increase, which is why we want to ask as many people as possible. All right, next question. This, I originally guessed C and D. I was able just quickly right off the bat to narrow it down. So how would I narrow down the question? This is interesting, but I can find the center of the data. So they said, once upon a time, we had a population of 10,000 shellfish. And where would 4,000 of those fall? They gave us the mean and the standard deviation. So when I look at that, if I looked at 4,000 of them, their center should be at the same mean 10. And I notice C and D are the only two that have a middle of 10. And so definitely C and D. So now I have to figure out, well, what are they asking exactly? And this is kind of a algebra question that we don't go over a lot. So let's review this one. This is kind of a good question. It's kind of a sneaky one. So it says, what if the whole population, so the whole area under the curve is 1, or 100% of the shellfish, the whole area is 1. If 4,000 of them fell within this range, you'd assume it would be right here, right? 40% would fall within this range, and you're trying to find out what number that would be here. Again, 40% fall with this range, and you're trying to figure out which number falls there. So that would be 20% to the left and the right. So you're looking at the inner 4,000 out of a total of 10,000. Now looking at this again though, that would be 0.2 is above the mean, and you'd think of it, because when I look at z-score, that's the area under the curve to the left. So I actually am trying to use the calculator and do an inverse normal calculation. What is the value at the 70th percentile, or if I know the area under the curve is 0.7, and the mean is 10, and the standard deviation is 0.2. So using my fancy calculator, I type that in. I find inverse normal distribution. I type the area under the curve is 0.7, the mean is 10, the standard deviation is 0.2, and notice I get the value of that upper one. I could have also chosen this lower one. The area I'd be looking for there would be 0.3. I could have also found the lower one. Either one would have worked. And so when I look at that, my calculator gives me the value of D. So I have to eliminate C, and I notice my answer is D. The value my calculator gave me does match D as in dog. Thanks for joining us.